Hey guys, we are going to talk about multiplying and dividing radicals. This is lesson 2.2. So example 1 says radical 2a cubed b to the fourth times radical 6a cubed b to the fourth. Okay, so first thing, notice the root. I'm just going to kind of like make a note of the root. So the root for this particular problem is 2. It's a square root. Root is 2. The only reason I'm doing that is just so I know, like, when I do eventually want to break anything down, I know the root is 2. Okay. So first thing I'm going to do, and this is going to make your life easier, instead of trying to break down this radical and then break down this radical and then multiply, first thing we're going to do is we're just going to multiply what's inside the radicals together. So 2 and 6 multiplies to 12. A cubed and a cubed multiplies to a to the 6th because we add the exponents. B to the 4th and b to the 4th is b to the 8th because we add the exponents when we multiply. Okay, now I'm going to simplify this radical. So like we did in class, I'm going to do radical 12, radical a to the 6th, radical b to the 8th. So I do them all separately. This just makes it more clear for me. So let's start with radical 12. I'm going to think about all the perfect squares I know and think about the biggest perfect square that goes into 12. The biggest perfect square that goes into 12 is 4. So radical 4 times radical 3. And radical 4 when simplified is 2. So this is 2 radical 3. And I'm going to circle this because I want to include it in my answer. Square root of a to the 6th. Okay, well remember we talked about the exponent being divisible by the root. So in this case, the exponent is 6 and the root is 2. And 6 is divisible by 2, which gives me a cubed. Lastly is b to the 8th. So again, the root is 2, 8 is divisible by 2, and that gives me b to the 4th. So these also need to be included in my answer. So now when I write my answer out, I'm going to include everything in front of the radical that's not under the radical. So 2a cubed b to the 4th. And then anything under the radical goes under the radical. There we go. And remember, I can always check if this is correct by squaring it. That is actually a little difficult in this case because our original problem came from here, which was 2 problems split up. Okay, so let's go on to talk about just in general. When we multiply radicals, what we want to do is, as long as they have the same root, notice it says here, same root. As long as they have the same root, we're just going to multiply the radicands together. So all of this can be written as the nth root of a times b. That's just kind of like our general rule. Okay, example 2. So first thing I want to do is I want to identify the root. The root is 3. This is a common misconception or mistake, is that people don't pay attention to the root, and then what ends up happening is they do the square root of these things. And then obviously we're going to get a different number, a different value that's not going to be equivalent. So I have to pay attention to the root. Now this is a division problem. I want to divide and express my answer in simplest form. So just like we did with multiplication, before I simplify anything, I'm going to divide first. It's going to make my life a little bit easier. So I'm going to divide everything under the radical. One thing I want you to notice is that this can be written all under the same radical, just like this. These two expressions are totally equivalent. They mean the same thing. Just know that. So I'm actually going to simplify what's under the radical. 27 divided by 3 is 9. B to the 7th divided by b is b to the 6th. And now I am going to simplify if possible. The cube root of 9. Okay, how many of you wanted to say 3? Be careful. 3 times 3 times 3 is not equal to 9, right? It's equal to 27. 9 is actually not a perfect cube, and there is no perfect cube that's evenly divisible, or that 9 is evenly divisible by. So actually the cube root of 9 is just going to stay as is. But let's talk about the cube root of b to the 6th. So the cube root of b to the 6th, let's see. Well, I want to do exponent over root, or power over root. So the 6th power divided by 3 is 2, so that gives me b squared. So I have the cube root of 9 times b squared, so I can write that like this, b squared cube root of 9. Notice how I really put that cube root inside of that little check mark, so as to not mix up the squared and the root, okay? So just be careful about that, keep that in mind. So now let's go to same thing, like a general rule for dividing. The nth root of a divided by the nth root of b is the same thing as just writing it all under one radical, a over b. Okay, so keep that in mind. What's really important, again, is that they have the same root. So in this case, the root was n. They both have a root of n. Keep that in mind. Okay, we have 2 more examples. So example 3, another division problem. Cube root of 324, a to the 4th, b to the 3rd, over the cube root of 6ab squared. Okay, so what we want to do first is we want to divide what's under the radical. So again, you can write this all under one radical. 324, a to the 4th, b cubed, over 6ab squared. This also kind of helps you see, like, I can divide what's under there. So I'm going to divide 324 by 6, and I get 54. And I am going to divide a to the 4th by a to the 1st. I get a cubed. And I'm going to divide b to the 3rd by b squared, and I get b to the 1st. And this is all still under the cube root. Okay, with me so far? So now I need to think about a perfect cube that goes into 54. So remember your perfect cubes. Go through them. 8, 27, 64. Well, now 64 is too big. So let's think about 27. Can 27 go into 54? 27 does go into 54 twice, which is great. So first I'm going to write this out all separately. Okay, and now 54 can be expressed as the cube root of 27 times the cube root of 2. And the cube root of 27 is 3. And then this 2 just stays under. Now the cube root of a cubed, well, 3 is divisible by 3, and it goes in once, so that gives us a to the 1st. And then the cube root of b to the 1st. If you remember from class today, we said that if the exponent is smaller than the root, then it means that we really can't break it down this way, so we can kind of just stop. So this is going to stay the same. Okay, and I'm just going to write this in a more coherent way. So the 3 and the a are out front, and the 2 and the b are under the cube root. Here we go. All right. So we have one more we're going to do together, and this one kind of encompasses multiplication, but also simplification, and it throws in another element. So first thing we're going to do is notice that we have parentheses. If there is anything we can do inside of the parentheses, then we'll take care of it. But it doesn't look like there's anything we can do. We'll talk about addition and subtraction tomorrow or in lesson 2.3. So not much we can do. We can't combine anything inside. So what we want to do is we want to distribute this 2 radical 6 to both of the terms inside the parentheses. So when we multiply it with the 8, I only multiply the coefficients together. So 2 times 8 is 16, and the radical 6 stays with it. So it's like I'm multiplying all 3 of these things. I'm multiplying, I'll show you outside. I'm multiplying 2, radical 16, I just made that up, radical 6, and 8. When I multiply those, the 2 and the 8 become 16, and the radical 6 stays. Now I'm also going to distribute this to the negative 4 radical 3. Okay, well 2 times negative 4 is negative 8. And then the radical 6 and the radical 3, they're both under the same radical, it's square root. So we can actually just multiply them together. So 6 and 3 is 18. At this point, I'm going to check if I can break down any of the radicals at all. So let's start with radical 6. When you think of a perfect square that radical 6 is divisible by, well, the only thing I can think of is 4, and radical 6, and 6 and 4 are not evenly divisible. Okay, so let's look at 18. Can you think of a perfect square that goes into 18? Well, I can think of 9 times 2, and then that breaks down to 3 radical 2. So let's try to put all this together. Let's try to write this in a coherent way. So this stayed the same, 16 radical 6. Okay, and then we still have the negative 8. And then we broke radical 18 down to 3 radical 2. So we're going to put that in place of it. Notice the negative 8 and the radical 18 were being multiplied. So this is going to just be multiplied. We're just really putting this in place of the radical 18. Okay, and I can do a little simplifying. So 16 radical 6 minus 8 times 3 is 24 radical 2. Okay? Again, we'll talk about adding and subtracting in lesson 2.4, and you'll see that you'll see if we can do anything else from here. All right? So that's it for now, guys. Make sure you write a reflection. Make sure you write down any misconceptions or common mistakes that I said, and any that you can foresee happening. Okay?